So we already, on the last video, we just found out that when you do a position versus time graph, well, let's just list everything. In general, x is for position. Okay? When you find the derivative of position with respect to time, that gives you velocity. V stands for velocity. Question is, what do you get if you then derive velocity? What if you find the slope of velocity versus time? What does that give you? Well, the answer is it gives you acceleration. If we went back to the last problem and derived it again, I guess we could, let's just get this list down first. Okay, so the derivative of velocity with respect to time gives acceleration. Notice what we now have is a derivative of a derivative. The derivative of velocity, well, velocity is a derivative of position. So another way to write this is the second derivative of position, which is we write like this: d with a little square on it, x dt squared. I don't remember why the square goes on the d instead of on the x. I don't really remember that. Ask your calculus teacher. I know I learned it in calculus, but I was your age when I learned that. Okay? Now, that's as far as we go and as far as we care about in this class, but in case you're curious, the third derivative of position, so the derivative of acceleration, basically, that's called a jerk. Jerk. I don't remember if there's a symbol for jerk. I think there is, but I don't remember what it was. You could probably look it up. The fourth derivative of position, that's a d, is called a snap. The fifth derivative is called a crackle. And what do you think the sixth derivative of position is called? That's right, and I'm running out of room. It's going over here. Great finale here. It is called a pop. I'm not kidding. These are in a book somewhere. You look it up anywhere, and that is what it says. Okay? So position is where you're located. First derivative of position is velocity. Second derivative of position is acceleration. Third derivative, jerk. Fourth derivative, snap. Fifth derivative, crackle. Sixth derivative, pop. We only care about these.